Hello, good morning and welcome to today's class. In today's class, we shall be looking at simultaneous linear and quadratic equations with the following objectives. 1. That at the end of this course, about 80% of the students should be able to solve simultaneous linear equations problems. You should also be able to solve a pair of equations where one is linear and one quadratic analytically. 3. You should be able to solve a pair of equations with one linear and one quadratic graphically. And also, you should be able to apply the principles of solutions of quadratic equations to related problems. And finally, you should be able to solve word problems leading to simultaneous and quadratic equations, be it linear or quadratic. So let's look at simultaneous linear equation. We said an equation of the form ax plus by is equal to c is called a linear equation where a, b and c are integers, and where this is said to be a linear equation. When there are two, we refer to it as simultaneous equations. Now, why are they related to the linear equations? Remember in our previous class, we said other types of equations. We said a linear equation is an equation that has one as the highest power of the unknowns. In this case, we have the unknowns to be x and y, where we said a, b and c are integers. So our unknowns in that equation are said to be x and y, which are two unknowns. So two unknowns always result in a simultaneous equation. So this is an example of a simultaneous equation when there are two. So the only way you can solve them is to solve them simultaneously. We said where a, b and c are integers. And we have three methods of solving simultaneous linear equation. And they include the substitution method, the elimination method, and the graphical method. In the course of this class, I'm going to show you how to solve simultaneous linear equations using these three methods. So let's take some examples. Example 1 says solve the equation 2x minus y is equal to 8 and 3x plus y is equal to 17 simultaneously using the substitution method. When you have a problem like this and you are asked to find the solution of such a problem, what that means is find the value of x and y that when you substitute it in any of these two equations, what you have on the left hand side will always give you the corresponding value of what you have on the right hand side. That is, after solving this and arriving at one value for x and the other for y, those two values should be such that if I should call this equation 1 and call this equation 2, that my value of x in equation 1 should also be the same value of x in equation 2, same with y in equation 1 and equation 2, such that if I substitute both values into equation 1, it will return a value for me as 8. And that same value, when substituted into equation 2, will return 17 as your answer. So I'm going to solve these two equations using substitution method. Now in substitution method, what are the procedures? In substitution method, since you have two equations, substitution method says you make either x or y the subject of the formula in either of the equations, be it equation 1 or equation 2. Substitute such value into the other equation and simplify. That becomes a linear equation of one variable. When you solve it linearly, you now find the value of y, and you resubstitute it to get your value of x. This is what I mean. Solution. I'm going to rewrite both equations. This is 2x minus y is equal to 8 and 3x plus y is equal to 17. Let me call this equation 1 and this equation 2. I'm going to make x the subject of the formula in equation 1. Okay, let me make y the subject of the formula in equation 1. Now this becomes, from equation 1, we have it that 2x minus y is equal to 8. This becomes 2x minus 8 is equal to y. Call this equation 3. I will now substitute 2x minus 8 for y in equation 2. That is, wherever I see y in equation 2, I'm to write 2x minus 8. That is, this becomes 3x plus 2x minus 8 is equal to 17. This has now given me a linear equation in one variable. So what we do next is to get our value of x and substitute it into equation 3 to get our value of y. That is, 3x plus 2x now becomes 5x minus 8 is equal to 17. Let's solve for 5x by adding 8 to both sides. This becomes 5x is equals to 17 plus 8. This is 5x is equal to 17 plus 8 is 25. And when you divide both sides by 5, you have your x to be equal to 25 divided by 5, which is equal to 5. Now I have gotten my value for x to be 5. But I said that 2x minus 8 is equal to y in equation 3. So since I have gotten my value of x to be 5, I will now substitute my value of x for 5 in equation 3. So we'll say substitute x for 5 in equation 3. So I'm going to rewrite equation 3, which says 2x minus 8 is equals to y. That is, 2x minus 8 is equal to y. So doing the substitution, we have 2 times 5, 2 times 5 minus 8 minus 8 is equal to y. That is, 10 minus 8 is equal to y. And what will be our y? Y is equal to 10 minus 8 is 2. So that is, x is equal to 5, while y is equal to 2. And how do you know if you are right or wrong? Let's resubstitute them into this equation to see if our answers are going to be 8 and 17. We got our x to be 5 and y we say is 2. So let's substitute and see. This is 2x minus y. This becomes 2 times, what's our value of x? 5 minus y is what? 2. Would that be equal to 8? Let's see. This is 10 minus 2, which is equal to 8. That means our value for x and y, they are both correct. Equation 2, let's test for equation 2. That is 3 into bracket x. X is what? 5 plus y, which is 2. Would that be equal to 17? Let's see. 3 times 5 is 15. 15 plus 2 is equal to 17. So that shows you that with values of x being equal to 2 and y, values of x being equal to 5 and y equal to 2 gives you the solution of this simultaneous equation. Let's solve another problem using elimination method. Example 2 says we should solve the following pair of simultaneous equations using elimination method. Elimination method is quite different from, it's just a little bit different from the substitution method. But in elimination method, what we do is we do direct either addition or subtraction of equation 1 from equation 2. And we can only do that when the coefficients of either x or y are same. Why? Because we are trying to eliminate it from a 2-term linear equation to a 1-term linear equation. One unknowns. So we either eliminate x or y. And how do we do that? By ensuring that the coefficients of either x or y are equal. For example, the coefficient of x of y in equation 1 is 2, and the coefficient of x y in equation 2 is 2. So what do we do? Since they are both equal, we move straight ahead to eliminate. But what if they are not equal? What do we do? So I will reserve it. I will not eliminate equation 2 y. I'm going to eliminate x. Being that they are not equal, I'm going to make them equal and eliminate x. Now, how do we make them equal? Since the coefficient of x in equation 1 is 3 and the coefficient of x in equation 2 is 1, I'm going to multiply equation 1 by the coefficient of x in equation 2, which is 1. I'll also in turn multiply equation 2 by the coefficient of x in equation 1, which is 3. By doing that, I have made the coefficient of x in both equations to be equal. Now, I'll multiply every term in that equation 1 by 1, and multiply every term in equation 2 by 3. So this is going to give us 3x minus 2y is equal to 7, equation 1, and equation 2 will give me 3x plus 6y is equal to minus 9 in equation 2. So I'm going to subtract equation 1 from equation 2, thereby eliminating x. 3x minus 3x is 0x, so this becomes 0, while 2y minus 6y is said to be minus 8y, which is equal to 7 minus 9 is said to be plus 16. Now I have made this to be a linear expression or a linear equation in one variable. Therefore, I can get my value of y by dividing both sides by -8. So when you divide both sides by -8, you have y to be equal to 16 divided by -8, and that will be equal to -2. Now, this is my value of x, of y. What is my value of x? Since I have gotten my value of y to be equal to 2, I will now substitute the value of y for either equation 1 or 2 to get my value for x. That is, since equation 1 is 2x, 3x minus 2y is equal to 7, I can now substitute 2 minus 2 for y in that equation and get my value of x. That is 3x minus 2y is equal to 7. 3x minus 2 into bracket minus 2 is equal to 7. Then I will simplify out. This becomes 3x plus 4 is equal to 7. Solve for x. This becomes 3x is equal to 7 minus 4. 3x is equal to 7 minus 4 is 3. And when you divide both sides by 3, what will be your answer? X becomes 3 divided by 3, which is equal to 1. So it therefore means that x is equal to 1 when y is equal to -2. And when you substitute into this equation, it gives you your value of 7 and -3 respectively. So let's try it and see. This becomes 3 into bracket. We say we got our x to be 1. Okay, so that is 3 into 1 minus 2 into -2. Let's see if it's going to return 7. This becomes 3 minus 2 times -2 is plus 4, and 3 plus 4 is what? 7. So that shows that our value for x and y in equation 1 are correct. Equation 2 says x plus 2y is equal to -7. So if you solve that, let's see if it will give us x is 1. So this is 1 plus 2y, that is 2 into bracket minus 2. Will it give us -3? Let's wait and see. This is 1 minus 4, and 1 minus 4 is what? -3. That shows that our values for x and y are correct. Equation 3 says we should solve the following pair of equations. Y is equal to 3x plus 2 and x is equal to 4 minus y graphically. Now, in solving these equations graphically, what you're expected to do is, first and foremost, is to draw a table of value for both equations and thereafter plot them simultaneously. So I'm going to draw a table of values for both equations, and then you choose your value of your intervals, and you ensure that your values, your intervals, are such that they will give you the required point necessary. Now what that means is, I'm going to draw a table of values for x and y, solving it graphically. You draw a table for x and y, and you plot a graph of equation 1 and equation 2. The point at which both graphs intersect gives you two values of x and y. Those values of x and y are said to be the solutions of that equation. That is, let me draw the first table of values. This is said to be the value for x. This will be for 3x. This will be for the constant 2 and y. So this is for x, this is 3x, this is for our constant 2, and this is for our y. So I'm going to pick my intervals to be from -2 to +2. Okay, so this is going to be -2, -1, 0, 1, and 2. Okay, so let me wipe this off. Okay, what that means is, if x is equal to -2, what will be 3x? I'm going to substitute -2 for x in this, or by using multiplying -2 by 3, and that will give me my value for 3x. That will be -6. I will do same to this. This becomes -3. This is said to be 0. For 3 times 0 is 0. This is said to be 3 times 1 is 3, and 3 times 2 is 6. So my positive 2 is a constant, so it's going to run through. So this is +2, +2, +2, +2, +2. While the value of y is said to be the sum of 3x plus 2. So I'm going to sum up all the values of 3x plus 2 to get my corresponding values of y. -6 plus 2 is said to be -4. This will give us 3 plus 2 is -1. This is plus 2. This is said to be 5 and 8. So this is my table of values for y is equal to 3x plus 2. Let me also construct that for the second equation. This is x, this is y. Okay, I will also use the same interval as that which I used in the first graph. 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. So this is value for x. But you first of all make y the subject of the equation in this equation. So this is going to be, when you take minus y to the other side, becomes y to be equal to 4 minus x. So I'm going to plot a graph for 4 minus x with intervals -2, -1, 0, 1, 2. So okay, I'll get my value for -y and positive 4. So if x is -2, what will be minus x? This will be +2, this will be +1, this will be 0, this will be -1, and -2. So 4 is a constant value for every term, while y is the sum of minus x plus 4. So this becomes 6, as 2 plus 4 will return 6, 1 plus 4 is 5, 0 plus 4 is 4, -1 plus 4 is 3, and -2 plus 4 is 2. Now I have gotten my values for both x and y for the two equations. I'm going to plot them graphically. So let's take a new page. So this is going to be my graph. Let this be our values for, this is my y and this is for x. So this is our origin, which is 0, 0. So let this be 1, let this be 2. But before you do that, in choosing your scale, you need to find the highest maximum and minimum value of y, and that will give you the length of your graph. So the highest value of y is 8, while the least value is -4. So that should be my interval. Let it be 1, and this is 2, 3, where I have -1, -2, -3. Values of y, this is -1, -2, be -3, -4, -5. Positive values, I have 1, 2, 3, 4, 5, 6, 7, and 8. But you know, when you are making use of your graph, you draw to scale. So I'm going to plot the graph in turns, one after the other. So I'll start by plotting the graph of y is equals to 3x plus 2. That is, when x is equal to -2, y is equal to 4. So where is that point where x is equals to -2, y is equals to -4? -2 -4 is said to intersect at this point. So this is said to be the point. I'll do that for each of the values. That's -1, -1, -1, -1. So we say to intersect at this point. The next is 0, +2. 0, +2 is said to be here because at this region x is 0, y is -2. 1, 5, where x is 1, y is 5, is said to be at this point. And the next is 2, 8. 2, 8 is said to be, this is 2, and 8 is said to be here. So I'll now draw a straight line graph. Please, when you are doing this, you ensure you make use of your rule. Mine is just a sketch. So when you are done, you also write the name of the graph that you just plotted, which is y is equal to that should be 3x plus 2. So this is y is equal to 3x plus 2. Next is to plot the second graph, the second table, on that same graph sheet. So -2, 6 will be when x is -2, 6. This is -2, 6 is somewhere here. The next is -1, 5. This is -1, 5. Should be somewhere here. -1, 5. Next is 0, 4. 0, 4. This is 0, 4. So it's going to be on this. Where we have 1, 3. 1, 3 is somewhere here. 2, Is it 2 comma 2? 2 comma 2, yes. So 2 comma 2 is on this. So I'm going to draw a straight line graph as well. So let's assume this is a straight line graph. Although they are all going to be on the same graph, but in a situation where not all points are in line, you pick the line of best fit, where you have if not all points are on a straight line, you pick the line of best fit, which is said to be the maximum point that can fit into the line. Okay, so in this case, one can be left out while others are in line. So how do we solve this graphically? Now, you look at the point of intersection of the two graphs. This is a graph of y is equals to 4 minus x. You look at the point of intersection where they intersect. That gives you, at this point, you can get your solution. So trace this down. Where it touches the x-axis, that gives you the value. So for this, I may take this to be approximately 0.4. While from here you take it this way, and this can be said to be approximately 3.2. So the solution of this simultaneous equation can be said to be x being equal to 0.4 and y being equal to 3.2. So this is said to be the solution of that equation, or you can approximate it. So what you do is take it back and substitute into this equation to see if they will both give you the corresponding values. Our next question says we should solve the following simultaneous equation. Now, this is a three expressions that are said to be equal. So in order for you to solve this, you will pick them in pairs simultaneously to form two equations. That is 4x minus 3 being equal to 3x plus y could be said to be equation 1. That is, I picked the first and the second expression. Next is to pick either the second and the third, or the first and the third. So this becomes 3x, I'm going to pick the second and third, plus y being equal to 2y plus 5x minus 12. Call this equation 2. So I'm going to simplify equation 1 and equation 2 and then solve both of them simultaneously. So from equation 1 we have it that 4x minus 3 is equal to 3x plus y. Let's rearrange. This becomes, I'll move all the variables to one side and the constant will be on my right hand side. So this becomes 4x minus 3x minus y is equal to 3. That is 4x minus 3x is x minus y is equal to 3. Okay, so I'll call this equation 1. I'll do same to equation 2. That is 3x plus y is equal to 2y plus 5x minus 12. Collect like terms. This becomes 3x minus 5x plus y minus 2y being equal to minus 12. Let the constant sit at the right. This becomes 5x minus 3x minus 5x, that will be minus 2x, y minus 2y is said to be minus y being equal to minus 12. Call this equation 2. So at the end I have formed a simultaneous equation. But I can also do something by factorizing out minus 1. This becomes minus 1 into brackets 2x plus y is equal to minus 12. Dividing both sides by minus, this becomes positive. So that my equation 2 now becomes 2x plus y is equal to 12. This is equation 2, my new equation 2, while the equation 1 is said to be x minus y is equal to 3. X minus y is equal to 3. Equation 1. You can then solve this simultaneously using either elimination method or substitution method. Solving both equations simultaneously, I'm going to use elimination method. I'm going to eliminate y because the coefficient of y is said to be constant. So I'm going to add equation 1 to equation 2 to eliminate y. That is 2x plus x is said to be 3x. Y plus minus y is said to be 0, which is equal to 12 plus 3 is 15. Dividing both sides by 3 to solve for x, your x becomes 5. Now I have gotten x to be equal to 5. What will be my y? I will now substitute 5 for x in either of the equations. So I'm going to use equation 1. Equation 1 says x minus y is equal to 3. That is 5 minus y is equal to 3. Minus y will be equal to 3 minus 5. And minus y is equal to minus 2, where y is equal to 2. So my value for y is said to be 2, yx is equal to 5. And it is only 2 and 5 that you will substitute in this equation to make it equal. So we got x to be equal to 5, y is equal to 2. Am I sure? Let's confirm. Y is 2, x is 5. So when you substitute x for 2, x for 5 in this equation, and y for 2, what you have here, this expression ought to be equal to this, and as well as equal to this. So let's see. This becomes 4x, that's 4 times 5 is 20. 20 minus 3 is 17. Will it be equal to this? Let's see. This is 3 times 5 is 15 plus 2 is 17. It means it is equal. And also, let's look at this. This is 2y, which is 2 times 2 is 4. 4 plus 5 times 5 is 25. 4 plus 25 minus 12. 4 plus 25 is 29. 29 minus 12 is 17. That means these three expressions are said to be equal. So the solution of this equation is x is equal to 5, y is equal to 2. Let's take our last question for today. Now we should solve the pair of simultaneous equations. That is 2 raised to power x plus y is equals to 32, and 3 raised to power 3y minus x is equal to 27. This is equation 1 and this is equation 2. Solving them simultaneously. Now these are said to be indical problems. So I'm going to apply so many techniques in solving this, not just normal, just that of indices and simultaneous equations. So equation 1 can be simplified to be 2 raised to power x plus y is equal to 2 raised to power 5 because 2 raised to power 5 is said to be 32. So, if 2 raised to power x plus 5, x plus y is equal to 2 raised to power 32, it therefore means that for these two to be equal, it therefore means x plus y, which is the power, must be equal to 5. This is one of the laws of indices. So I'll call this equation 1. I'll also do same to equation 2, which says 3 raised to power 3y minus x is equals to 27 can be written as a multiple of 3 to be 3 raised to power 3. So we say equal this equate powers, that is 3y minus x ought to be equal to 3. I'll also call this equation 2. So bringing equation 1 and rearranging it to be in this form, by bringing y forward, I'm going to have y plus x is equal to 5. This is equation 1. Solving them simultaneously, you will get your answers. So at this point, you can either use substitution method, elimination method, or graphical method. But I would advise you to always make use of substitution method or elimination method in preference to graphical method. For graphical method, will always take much of your time. So I'm going to use substitution method. I'm going to make y the solution of the formula in equation 1 and substitute it into equation 2. So from equation 1, you agree with me that y will be equal to 5 minus x. Call this equation 3. You now substitute y, 5 minus x for y in equation 1. So this becomes 3 into brackets 5 minus x is equal to 3. This becomes 15 minus 3x minus x is equal to 3. Collect like terms by moving 15 to the other side of the equation. This becomes 15 minus 4x is equal to 3 minus 4x is equal to 3 minus 15 minus 4x is equal to minus 12, and x will be equal to minus 12 divided by minus 4, which is equal to 3. I have gotten 3 to be x, of which we say from equation 3, we said y is equal to 5 minus x. If x is equal to 3, then I'll substitute again my value of y. Y now becomes 5 minus 3, which is equal to 2. So if y is equal to 2, then let's see if it will give us our answer. That is, we say y is equal to 2, where x is equal to 3. So let's substitute to see if this will give us our equation. Yes. For we say this is equal to 2 raised to the power 5, or x is equal to x plus y is equal to 5. This becomes 2 plus 3 is equal to 5. Or equation 2, which says 3y minus x is equal to 3. So 3y is what? 3 times 2, which will be 6. 6 minus x, which is 6 minus 3, is equal to 3. So that means our solutions are actually correct. So that brings us to the end of today's class. In today's class, we were able to solve simultaneous linear equation problems that are both linear by using graphical method, substitution method, and elimination method. Thank you for being part of the class. See you tomorrow for our next objective. We say we should solve a pair of equations where one is linear and one is quadratic graphically. See you tomorrow and you have a nice day. Please, before you go, kindly like our video, and you can also use the comment section for your questions, and somebody will be there to attend to you. Also, we encourage you to subscribe to this channel so as to get more videos as they are being uploaded. Thank you very much and do have a nice day.